This is the last part of the A4 where we're looking at breaking down problems and designing an algorithm. In the next step, we're going to be looking at actually designing some pseudocode and flowcharts. But before we do that, let's dive a little bit deeper into breaking down a problem in the last section, A4 algorithm design. So an algorithm is a set of instructions that you follow to complete a task. So you break the task down into a series of structured processes that will occur. And sometimes an algorithm might have other algorithms inside it. So when the algorithm is doing a job, like say it's a card game, one of the algorithms might be to shuffle the cards. So it will have algorithms inside the algorithms, and that's very common. So we're going to do this by looking at an example. And the example we're going to look at is one that I'm actually going to code up in class to help you see the link between the design and the implementation. We are not really concerned with implementation today, but I thought it would be good for you to actually see that link. So the task we're going to look at now is how to convert pounds into dollars or to euros. So imagine this is a very small web app, and the user can input some amount of money into a box. They can choose whether they want dollars or euros, and then it will convert the amount and give them the answer in either dollars or euros. So let's have a look at how we might approach this and break it down. So the first thing is make sure that you understand the problem in the first place. You can't design an algorithm for something if you're not sure what the problem is. So just to reiterate that, we need to convert an amount in pounds entered by the user into either euros or dollars, and then output the answer. So once you're clear on what the specific problem is, you can then start to look at the steps to solve that problem. So the first thing I would do is think about what is the user going to do? What are they going to input into this system? And what type of data might I need? So the user is going to input an amount in pounds. So that will be a decimal number. So like 3.2. We don't want the user to include a pound sign. We just want a decimal number. Then the user is going to make a choice, either dollar or euro. And we've got to store that choice somehow. And there's different ways we could do it. One way we could do that is we could use a string variable to store the word dollar or store the word euro, or shorten that to E or D. There are other ways of doing it. We could assign a numerical value to each choice, or even Boolean value. But for now, we'll just keep it as E or D, and a decimal value for the pounds. Okay, after we've got the information from the user, we need to think about what calculations we're going to do. Are there any special values we need to know? So if we were creating a program to calculate the area of a circle, we would need to know the value of pi. In this case, we need the conversion rate for the pounds to dollars and pounds to euro. So those two numbers, we actually need them before we can begin. We then need to check the user has input a valid number. What if they type a letter in, or if they type a pound sign in, or they type an invalid number with two decimal place, two dots. What if they type something invalid in? Then we can't convert it, and we need to tell the user it's not a valid input. We also need to get this choice of either euros or dollars. After the user's input some information, we'll need to save that temporarily. We don't need to store it on the hard disk for next time the application is loaded. We need to just store it temporarily in variables. This is called caching, while the application's running, but there's no actual storage needed for this. If it was a program to log the sort of conversion rate over a period of time, we'd need to save the conversion rates over a period of time, so we'd need to store that in a text file or something. But for this application, we don't need that. We need to think about what will be output by this program and what format that output would be in. So if we're doing money and it's going to be in dollars or euros, we expect it might be something like $1.65. We'll need a decimal number. It'll need to have two decimal places, and it will need the correct sign, either a dollar or a euro symbol. So one way we can think about organizing our thoughts is to use a quad diagram. So quad just simply means four boxes to represent the different parts of this process. So the inputs, the outputs, the processes, and the data. So in each of one of these boxes, we'd record what we've just discussed, the inputs, the outputs, and any processes. So that could help you organize what you're going to do before you write the program. So in summary, what you do is you make sure you understand and define the purpose of the program. So you know exactly what the program will do, the limits of the program, and how it, what its functionality will be. You need to very clearly understand the problem before you begin. The next step is you need to then split the program into some different processes that will occur. Like we've just looked at, we got the inputs, we did some processing, and then we got the outputs. We need to plan the steps for each process. So within those little processes, things will occur inside them. And then once we're finished, we need to check that it actually does what it needed to do in the first place. So if it needed validation, we need to check that validation works. So I'm going to give you a task. So I want you to follow all the steps we've just done from 1 to 6 and make a quad diagram to represent the following problem. So this is quite a small problem, but I want you to think about it in sufficient detail. So you're going to design a program to convert kilograms into stones and pounds. So normally when you go on a number converter and you type in so many kilograms, it will give you an answer like, 10.2 stone. We don't want that. We want to know the value in stones and pounds. So I've put an example below. If the user input 71 for 71 kilograms, the output would be 11 stone and 3 pounds. It wouldn't be 11 stone point something. I want you to be as specific as you can when you design this program, as though you're actually thinking now about getting ready to actually program it. So just to clarify the problem, the user should enter an amount in kilograms. It should be validated that it's a valid amount, like you can't enter a negative weight, for instance. And then the program will display the answer in stones and pounds. The pounds should be rounded to the nearest whole number. So I don't want 2.56923 whatever pounds. I want it a nice, clean, simple output. I want you to design this program following the steps just outlined, and then hand it in on Google Classroom. You can ask for help if you need anything, and we will also on Wednesday be coding a live example of one of these types of programs to give you a really clear idea of how this design phase would then translate into an actual piece of working code. Thank you.